Going to wait to see if it's streaming. I'm going to spend 1 hour and a half here today and structure the scope video. I'm almost done with I finished the spreadsheets for the landing page. The stuff that I said that I was gonna add yesterday. And now I think the only thing that I'm gonna do left is to add the different fave icons. And then I'm gonna post the video hopefully today on TikTok, the first clip, and then I'm gonna start putting the link on the description. I think I'm gonna do the Italian thing today before I start this scope video. It's probably streaming. Yeah. And hopefully I can do more than one video today. Structure more than one video, then obviously I'm gonna have to film off stream. I saw this, I've seen some people that do these kinds of videos to do it. They do it on stream and then they cut later. But I think that's gonna be there's more work. And they do it like that probably because they have someone to edit for them, the videos. Yeah, code, Rust. Yeah, I'm gonna put the timer here for 1 hour and a half, then start this.
Fa,
Fa,
Does.
fisso.
fisso,
Set. Unchanging.
3.
3,
3.
Desiderare.
desiderare,
Desire.
Aria.
aria,
Air.
Bene.
bene,
Well.
Anche.
anche,
Also.
Giocare.
giocare,
Play.
Piccolo.
piccolo,
Small.
Fine.
fine,
End.
Mettere.
mettere,
Put.
Casa.
casa,
Home.
Leggere.
leggere,
Read.
Mano.
mano,
Hand.
Portare.
portare,
Carry.
Grande.
grande,
Large.
Compitare.
compitare,
Spell. Words.
Aggiungere.
aggiungere,
Add.
Anche.
anche,
Even. Also.
Terra.
terra,
Land.
Qui.
qui,
Here.
Devo.
devo,
I must.
Grande.
grande,
Big.
Alto.
alto,
High. Tall.
Tale.
tale,
Such.
Seguire.
seguire,
Follow.
Atto.
atto,
Enact.
Perché.
perché,
Why.
Chiedere.
chiedere,
Ask.
Maschi.
maschi,
Men.
Cambiamento.
cambiamento,
A change.
È andato.
è andato,
He. She went.
Luce.
luce,
Light.
Tipo.
tipo,
Kind. Of thing.
Spento.
spento,
Turned off.
Bisogno.
bisogno,
Need.
Casa.
casa,
House.
Immagine.
immagine,
Image.
Provare.
provare,
Try.
Noi.
noi,
Us.
Di nuovo.
di nuovo,
Again.
Animale.
animale,
Animal.
Punto.
punto,
Point.
Madre.
madre,
Mother.
Mondo.
mondo,
World.
Vicino.
vicino,
Near.
costruire,
costruire,
build,
se stesso,
se stesso,
himself,
terra,
terra,
earth,
padre,
padre.
father,
Okay, so how I'm gonna do this? I think I'm gonna search for modules, modules and namespaces. I think the principle of these things are the same. The of scope, function scope, modules, and namespaces. The only difference is the level of I'm not sure if abstraction is the right way to put it, but because it's different ways of organizing the information based on the boundaries that the data is gonna flow. But I'm not sure if in this video I'm gonna talk about, because I'm not very knowledgeable in namespaces. I understand the basics, but not the under the hood kind of thing of how the stack frames and heap change according to the namespaces in the organization of memory in the hardware. So I'm not sure if I'm gonna talk about this in the video. Probably not. Maybe I'll briefly mention these things here.
Welcome to the course on namespaces and scope in Python. In this course, you will learn what namespaces are and what kind of types of namespaces are used by the Python interpreter. You will also learn about variable scope and the LEGB rule. Finally, you will learn about modifying variables out of scope using the global and non-local keywords and some best practices that come with them. The code samples were tested using Python 3.9.0, and as far as I'm aware, all examples should work. You will have a closer look. For that out, you can run the following, which shows you that it is dictionary. You can use it to access the objects in the global namespace. Let's have a look, and for that out, you can run the following command: dunder builtins.st.dunder module. That means that the value of dunder builtins name is actually the built-ins module. This is indeed the module where all built-ins are located, as you can see when you import the build itself, but it's the built-in function global example of what it looks like when on your Python version of the value foo, and you can confirm the function. Now, new value to a variable using the same method. Until now, you have only worked with variables is added. With the interpreter with printing where the function g in the now the function g is added.
Python allows you to define variables at different places in your code. In this example, a is a global variable and is accessible from within both functions.
Well, this guy's channel is really good as well. He has a great video about Rust. I think I'm gonna watch this video again actually today. Maybe tomorrow. I forgot which one. I think this one is very, very good. This is the type of animation I was trying to do, but it's too difficult to do it with DaVinci Resolve.
When we write programs in Rust, we tend to focus more on how the memory layout of our program will be. If you don't do some upfront
The
design,
thing is, it's difficult to find information that explains how to do this. And the ways that I know or that I can think of right now, either takes too much memory in the GPU, or it's too hard to do it, or I just don't know how to do it. Because in DaVinci Resolve, you can create shapes on the Fusion page. So one way would be to create a shape like this, and then put the text inside. But then you have to do the animations with keyframes. And to do the keyframe, when I try to do it, my VS Code, my DaVinci Resolve crashes.
of your data structures, the Rust compiler will likely make things difficult because of its ownership models and lifetimes. It's important to understand the memory layout of individual data types for better intuition when writing the programs and dealing with compiler errors. In this video, we will be discussing what happens when an operating system executes your binary, the memory layout of common data types like integer types, tuples, slices, vectors, strings, structs, enums, smart pointers, trade continuous range of memory from BSS stands for block started by symbol, and this segment contains uninitialized global variables. If your program's thread uses more than the stack memory, it will be terminated by the kernel, and you will see a stack overflow error. Stack memory is used for executing functions. So it's highly unlikely that either one of them will overwrite the other. Kernel provides guards to abort the program if such a situation arises. Note that these are virtual addresses. The kernel can use such large address ranges even if your memory is allocated for the program. A higher 141 terabytes is reserved for the kernel's use. 2. Main also has another local variable b, which is once they add one function returns, the return value 23 is stored in its local variable b. Also, the stack pointer is changed. Note that the stack frame on add1 isn't deallocated. It will memory. In a language with a garbage collector, the compiler will automatically detect this and allocate the variable on the heap memory and return a reference to it, but there is some extra cost to allocating on the heap. We will get into the detail. In this case, the 8 bytes used to store the address are copied from the heap function stack frame to the result variable. Now, even though the stack frame of the heap function is deallocated, the result variable contains the address of the data in the heap. Heap allows you to share data. We also mentioned that each thread has its own stack. but they
These
all share-
arrows here are extremely difficult to do in DaVinci Resolve as well. I only know how to do straight arrows, and the method that I know for creating arrows like this is not really good. And then there are other methods, but then my GPU is not strong enough to do it.
Share the common heap memory region. Let's suppose your program allocated more and more. Allocator uses this malloc function provided by the C library. When you use a tool like LDD to inspect the dynamic dependencies of your binary, you will see one of them is libc. This means that this Rust binary expects the C standard library or libc as a shared object or compiled library in the operating system at that location. This is a safe assumption because libc is more like part of the operating system, and such dynamic linking allows Rust with smaller binary sizes. Also, the memory allocator doesn't always use system calls to allocate more memory on the heap every time your program allocates something on the heap using box or something similar. Program's memory allocator requests memory in chunks to reduce the number of system calls. Also, unlike stack, memory is not always freed from one end of the heap. And when some regions of memory are freed, it's not immediately returned to the operating system.
Oh, I think I'll watch this video later.
X is a local variable of the function first and is not accessible outside the function. Everything is an object in Python, including functions. You define a variable X, an object is created somewhere in the memory, and we will have label X as a handle to that object. We say the variable or name is bound to the object. We will understand scopes using this example. Here, we have a defined outside the function and another variable prefix defined within the function. Also, inside the function, we print the value of both variables. The portion of the code where a variable is defined is called the lexical scope of the variable. Global scope is essentially the module scope, which means it spans a single file only. If you import another module, it will have its global scope. Each function has its global scope. Every time the function is called, a new scope is created. Certain Python objects like print function, none, true, false, are available everywhere in your program, and they are in the built-in scope. Variables or name bindings are stored in namespaces. Every scope has its namespace. Namespaces can be thought of as
Yeah, I think I'm gonna take a picture of this, and I'm gonna I don't think reference is the right word, but I'm gonna give credit to this guy, and I'm gonna use this picture. And obviously, my explanation is gonna be different. I'm gonna use the analogy of the neighborhood, like I said. I'm gonna put his channel in the description of the video. Not sure that's how you spell Venn diagram, but whatever. Just so I understand what it is.
as a table of labels to object references it is pointing to. Namespaces of global and local scopes are implemented using dictionaries. When our code is executed, the namespace of the global scope will have two entries, one for variable a and another for the function my_func. Values correspond to the memory address at which this integer object and function object are stored. Then, when my_func is called, a new scope is created for the function, and its namespace will have an entry for the string variable prefix. In the built-in scope, I will just show an entry for the print function. There are many others. Now, let's focus on the print statement within the function. The argument to the print is constructed by joining local variable prefix and global variable a. For name resolution, Python starts from the current scope and looks outward until it finds the first match. Here, prefix is found in the local scope itself. Variable a is not found in the local namespace, so Python will look in the global namespace and it is available there. Next is the print function. Lookup happens just like others, and it is available in the built-in scope. The important thing to understand here is that, because of the way this lookup works, if you define your function with the name print, it will mask the print function provided by Python, and the rest of your code will use this masked function. The next example, I'm keeping the rest of the code same, and I'm trying to modify the global variable a from within the function. If you run this function, you get an exception stating local variable reference before assignment. Notice that the error is happening in our print statement. You may think that the print should have used the global variable a since we are only creating the local variable a after the print function. But this is not the case. Python determines at compile time, that is when it sees the def statement for the function, that the function my_func has a local variable a since you are assigning value to it in the body of the function. However, the value object, that is 35 here, is only created when the function is executed. Remember, a variable is only local if you assign them inside a function. If you only reference it, the variable should be available from an outer scope, usually from the global scope. So when you call the function and execution reaches the print statement, the local namespace already has an a. However, nothing is assigned to it. This entry masks the a in the global namespace. Hope that exception makes sense now. What if we wanted to modify the global variable from within the function? That's where the global keyword comes in. It tells Python that a variable is meant to be scoped in the global scope. Now, if you assign a new value to the global variable, the change will persist even when the function returns. In the next example, we are stating that the variable a is global and assigning a value to it. However, there is no variable a in the global scope. When the function is executed, a new entry is created in the global namespace for a. After the function is executed for the first time, this global variable will be available in the global namespace. However, just because you can doesn't mean you should. Creating a global variable in this way is considered bad code. In the next example, there is a global variable a and a local variable local var. Global namespace will have an entry for the address of a, but I will just put the actual value here. Also, the function takes an input parameter. They are part of that function's local namespace, just like any other variable you create within the function. You can use the globals function to get a handle on the global namespace dictionary. Along with others, you will see entries for variable a and function my_func. You can access the value of the variable using its name as the key. Same applies to the function. To execute the function object, use parentheses and pass the argument. Similarly, you can use the locals function inside your function to get the dictionary that acts as its local namespace. Although local variables are determined at the time when Python sees the def statement, their values are only evaluated when you execute the function. The exception for this is if you define default values for parameters in the function signature. I had covered those details in another video explaining how variables work in Python. You can use the covariance attribute to determine which all are local variables of your function. The next example, you have a global variable and an outer function, and then there are a function with a name inner defined within the body of the outer function. Let's see how scopes will look here. I'm omitting the built-in scope. In the global namespace, there is an entry for variable a and another for outer function. Within the local namespace of outer, there will be entries for its local variable x and inner function, since the inner function is defined within the body of outer. When the inner function is executing, a new local scope is created for it, and it will have a separate namespace. Since we are assigning to a variable x within its body, the inner function's namespace will have an entry for x. So the local variable x of the outer function will remain unchanged even after the inner function is executed. What if we wanted to modify x in the local namespace of the outer function from within the inner function? Let's see what will happen if we use the global keyword for this purpose. Global keyword says that we are accessing a variable directly in the global namespace. In this case, x doesn't exist in the global namespace, so a new entry will be created. This is not what we wanted. For this use case, Python provides the keyword non-local. Using the non-local keyword, we explicitly tell Python that we are modifying a non-local variable. Now, the value of variable x in the outer function's namespace will be modified. In the next example, we have one more level of inner functions. Within the local scope of inner1, there is only one entry since we didn't define anything else inside its body except the inner2 function. Within the body of inner2, we explicitly say that variable a is non-local. So Python will start looking and enclosing scopes, starting from that.
So I think the first example is better to do that. I'm gonna maybe I'll do a different function, but I think I'm gonna use this one. Let me take a picture. I'm gonna do this on in SkylyDraw. I'm gonna use this one, and then I'm gonna use the other one he talks about. I'm gonna start out with the analogy. Then, yeah, I think on this step I'm gonna show the picture of Venn diagram. And explain picture Venn diagram. That's variables are only accessible by going from the most inner layer to the most outer layer, but not vice versa. So if you declare a variable inside of a function, then you can't have access to the variable in the global scope. Then what else do we need to talk? Yeah, I think the question that I have is what namespace is a module, but I think it's the, yeah, maybe it is between global and this outer here. I don't want to copy, I don't take a picture of this because then it's just similar to his video. I'm just gonna take these pictures that I used and I'm gonna do them on SkylyDraw, and I'm gonna do a different type of representation and then talk about it in a different way because I don't want to copy him exactly.
Namespace. Since we are assigning to a variable x within its body, the inner function's namespace will have an entry for x. So the local variable x of the outer function will remain unchanged even after the inner function is executed. What if we wanted to modify x in the local namespace of the outer function from within the inner function? Let's see what will happen if we use the global keyword for this purpose. Global keyword says that we are accessing a variable directly in the global namespace. In this case, x doesn't exist in the global namespace.
Oh, then I can talk about JavaScript and Python. That's talk about how Python has the global keywords. For example, in SkylyDraw. And how JavaScript has the global window object that exists in the web browser. Explain how the browser creates the object. Yeah, that's a good thing to talk about. And also maybe mention local storage. That's also a good thing to talk about as well. Maybe cookies as well. But obviously, I'm not going to explain those things. I'm just going to mention them because they are. I'm going to mention them to the extent that they are relevant to scope. But the point of the video is not to explain these things. So yeah, I think I'll watch this stuff off stream.
So a new entry will be created. The next example, we have, so Python will start scope. In our case, there is no, the same as the previous one,
Yeah,
except
besides that, there isn't too much to explain, I think. What namespaces? What namespace are libraries?
Welcome back, everybody, to Programming Episode 2. So we're going to be talking about libraries and namespaces. Libraries are just code that the developers of a language put together to define the common things that we do as programmers. So one example is, as a programmer, we have to get input from the keyboard quite often. So instead of having to rewrite that code 1,000 times, we can just use the libraries that the developers made, and we can just use the code inside those libraries to do that. So here I have an example with this picture, just to prove that libraries are hierarchical. So a library could be named living things, and then inside that, we have two bookshelves. One is animals, another is plants, because both are living things. On each shelf, we have a different type of animal. So we have mammals and reptiles, and then each book on the mammal shelf could be like a different mammal. And then we have this librarian here. So this is just representing the compiler. So the librarian needs to know where to find books, and similarly, the compiler needs to know where to find files, and that's going to be our job. It's going to be our job as a programmer to tell the compiler where to look. Okay, so what are namespaces? Namespaces is the way in which we eliminate name collision, which just means if we have two functions in two separate files that are the same name, the compiler will be able to know which one we're talking about. So let's take an example. So let's say I had this program, and it just said speak. So here's our program, and it just says speak. And the compiler is going to get really confused because we have two functions that have speak in it. So
I think a good analogy would be libraries as well. I think I used this analogy in the past, but with books. I don't remember what I was talking about, but I remember saying that if you want to find specific books, it's better to have a specific room for each book in your house instead of leaving all the books in without any organization. So I think a library is a good analogy for this as well. So first mention the neighborhood and house, then explain the Venn diagram, and then talk about how it only goes from the inside to outside and not the other way around. Then talk about the global and other stuff. So maybe the analogy of libraries would be better here. I think right after this, also make an analogy. If a library, each book has the same, each book uses the same words, but because the book is different, the words are interpreted in a different context. Yeah, so if you have two different books that they both are in English, the language is the same, but the meaning is different because of the context. And the context is created through what the encapsulation of the book represents, which is the scope of the book. I think it's the same principle.
Our namespaces come in, we would say something to the likes of use cats and then speak. So now the compiler knows that it needs to go over to the cat file and use that speak function instead of the dog's speak function. So one thing to denote about different languages is that they can have different verbiage. For example, in C++, we call libraries libraries and namespaces namespaces. However, in Java, we call namespaces packages. Let's look at this example here. So this program is asking the user for their favorite animal, and then they type it into the keyboard, and then we respond saying your favorite animal is whatever they typed in. So the important thing to see here is this line right here. It says import.
That's obviously why it's called a library. So
util scanner. This is importing a package. It's specifying which namespace to use. The weird thing with Java that I found is that the libraries seem to already be included, whereas in C++ you have to actually say include this library and then use this namespace. In Java, however, we just have to specify the namespace. So we can actually find this file in the file hierarchy. So here in my file explorer, you can see this is where I downloaded the JDK, the Java development kit, and then I navigated over to the source, the lib, and then I found java.base because these are where the common libraries are going to be held. And then we have Java and util. So then you can see the scanners right here, and our line up here says java.util.scanner, and if we look again, we have java util scanner. So that's how we're telling the compiler where to look. So if we run this code, we'll see what happens. So down here in the console, it'll say, what's your favorite animal? And we'll just say a lion. Say your favorite animal is a lion. So if we take this line away, the compiler's going to be confused because it won't know what a scanner is. And you can see we already have errors here. So if I try to run it, it'll give us errors. Yep. Then we look here in the problems and we drop this down and it says scanner cannot be resolved. So it's wondering what the scanner thing is. So that's why we need to specify the namespace. Okay, like I briefly mentioned, with C++, we actually have to specify the name or the library that we're going to be using, whereas in Java, we really don't have to do that. We just have to specify which namespace. So we can think of C++ libraries as like individual libraries, and then we can think of Java as just one big library where we just have to specify the namespace. And then one other thing with Java is they have these things called modules, and this is just one extra abstraction layer. So in C++, we can have a library containing multiple namespaces, and then in those namespaces, multiple classes, and then multiple functions. And in Java, we just have one extra layer. So we have libraries that have multiple modules, and then those modules have multiple packages, and so on and so forth.
Yeah, so the different names they just should represent different layers of abstraction, but the principle is the same. So what changes between languages is the different layers of abstraction that encapsulate this concept of the enclosure between the meaning of the words, I think. So what changes from different languages is the amount of layers the language specifies. Some languages have modules, others don't. And modules are just another layer of abstraction. Yeah, the thing that I'm trying to think about now is the way that I'm thinking about doing this is to go on Google Maps, get a picture of a city and a neighborhood and the house. But then I'm not really sure because I'm not sure what I'm gonna be able to do with the animation. But I was thinking in my mind of getting a picture of a bicycle and then animating the bicycle inside of these boundaries. And then as I explain I make the analogy and explain how it works. I make the animation of the bicycle moving, but I'm not really sure if I'm going to be able to do this. Because animations are, like I said, they require more GPU power, I think. Yeah, but besides this, I don't think there's much to talk about. So I'm going to search for the pictures of a city. Neighborhoods, and the house. And it's gonna be difficult to find an image of the way that I'm envisioning in my mind. So I think I'm gonna search for in Google Maps. That's some random place. It has to be a small place that maybe Paris. Yeah, I think what I can do is just use this thing here. Maybe. Yeah, then I'm just gonna highlight the. I can also move as I talk about it. I can show the Google Maps thing and move. I think that's better probably. And then later when I'm starting to edit, then I'm gonna highlight things and then put the. I don't think I'm gonna be able to do the picture, the animation of the bicycle, but I can probably put a picture of the bicycle and then move the picture from frame by frame. Instead of animating, I just cut in different frames and then change the position of the picture. So put multiple different pictures. Yeah, so let me search for a picture of a bicycle. I'm not sure how to write this. Bicycle. And it's gonna be this one here. It's not saving the image. If I take a picture, I'm gonna have to remove the background anyway, so. I think I'm just gonna take the picture and then remove the background later. I think there is a site for this that I saved on the favorites. It's remove BG or something like that. I have so much shits on the favorites as well. Need to clean this up at some point. Yeah, remove background. Fair enough. I'll be right back. Now I'm gonna get the picture that I took there. And I'm going to translate this into SkyliDraw. Also, I realized that I can change the size of the text to increase by selecting the text after you write and then making it bigger. And didn't realize that in the beginning. For example, here is very small. And that's the problem of doing things here. Let's put a different number. Here I'm gonna put the same letter, same thing as I did there. Hmm. Okay, so starts out with the knowledge of city, neighborhood, and house. Show the picture of Venn diagram. Also make an analogy with a library. I think I'm gonna show the picture later. I'm gonna show the picture here. This picture. Because in this city it makes more sense that I use the Google Maps stuff, and then here, as I talk about this, I'm gonna show this picture, and then I'm gonna also talk about library. So maybe I should search for pictures of libraries as well. This looks very good. Not sure where this is. I think this is a good picture. I hate when it saves like this. I'm just gonna take the picture instead. Yeah, this also looks very good. I think it's gonna save in the same way. Oh, I can change the format there. Why I didn't think about that on the previous one. Yeah, but besides this, I don't think there's much I can do. Or have to do, I should say, about getting pictures and other resources to explain. I think it's pretty simple actually. It's difficult to explain, but it's not that difficult to there's not a lot to explain. But it's difficult to explain, but there's not a lot. What changes from different languages is amount of layers the language specifies. Some languages have modules, others don't. So as I talk about this, then show pictures of the libraries. Then explain in picture Venn diagram that variables are only accessible by going from the most in a layer. Yeah, this. So maybe I should put this stuff on top here. And then I put the picture of the Venn diagram and the code side by side. I want to be careful to not copy the other guy though. That's the thing. I think it's okay to copy if you change things and you explain in your own way. Because nothing is really new. Everything is always the same but different at the same time. So all this stuff that people talk about nowadays were discovered thousands of years ago through philosophy. The philosophers of thousands of years ago were already talking about all of the stuff that people talk about today. But the difference is the way that they express the information. So I think it's fine because they're not pretty much impossible to invent something new. I think you can only discover things. And the process of discovery is going to be a connection between things that already exist. And that's creativity. So I think it's better if you're striving to be fully creative and not copy anything. But realistically, that's extremely hard to do, so it's not practical enough. So the middle ground is probably copy and then put your own expression into it. What changes from different languages is the amount of layers. The language specifies, some languages have modules, others don't. Talk about how Python has the global keyword. Okay, yeah, that's the stuff that I have to study again. Is if the local storage is a global object. I think it is, but I'm not really 100% sure, so. And then talk about the window as well. Maybe I could talk about the different properties of the window object. Because I don't even know it myself. All the different methods. And local storage and cookies as well. Also, local storage is a method of the window object. Or property. Didn't know that. Yeah, I think I'm gonna take a picture of this and then I'm gonna put this link as well. So I'm gonna create another, maybe I don't need to create another, I just put here, link references. And then I put the...
Hello
Is-
and welcome.
Hey guys, how you going?
Hello, everybody.
I think I closed this video.
Many times when you're developing software, you're going to have a situation like this. You have a function, a class, a method, whatever it is, and you give it a specific name. So let's say it's a nice simple name like start. Well, let's say that some other developer that's working on your project also needs a start. And this could be, for example, here you're downloading an MP3 from the web, and over here you start playing the MP3 from the web. So both of these are legitimate enough names, and we wouldn't want to change them and say start play or start web download. That would just be a little bit ridiculous, and we'd have to check in with everyone. Well, namespaces are a solution to this problem. So if we have our two start functions, these can be contained inside of their own namespace. Or if you had two start classes or whatever it was, you would have a namespace here, which would be called perhaps web, and you'd have a namespace here, which would be called perhaps player. And sorry for my atrocious writing. Oh dear. So a namespace allows you to divide your program up into specific places so that the names inside of those bits of code don't get confused with other bits of code. So you can see it's very useful to avoid what you will commonly hear called namespace clash.
Oh, these are really good to talk about. I remember seeing this method here for, yeah, when I was researching how to transform the file, to send the file from the server in blob and then transform that file into in the front end as a blob as well. Then there was some answers on Stack Overflow that used this stuff here, and then I didn't know what it was, so I'm gonna take a picture of this as well.
So you've seen the assignment operator where we associate a value with a variable or a name or an identifier. So let's consider how Python is doing this. It uses a namespace. And a namespace we could think of as being divided into a list of names and a list of objects or values. And this is just something stored in computer memory. And if we write an assignment operation like x is equal to 3, it says, okay, here's a name. It's x, and I'm going to associate it with the value 3. Now, later on in our code, we might say x is equal to 7. And what Python will do is, well, it doesn't have a new name, but there is a new value here, and it associates that name with a new value. Now, this 3 that existed in the computer memory, it may still be there, but we don't worry about that. That's Python's job to keep track of these objects and values in there. Okay? And then if we increment x by 1, we get the former value of x was 7. We added that 1, we get 8. We reassign that to the value of x. So in memory, we have 8 there, and x is now associated with that. Okay, let's give another example of what goes on in a namespace. So here is a namespace, list of names, list of objects. We have an assignment statement, x is equal to 3. Don't write the arrow in red this time that's telling us that the value of x is 3. So 3 is associated with x. Let's add another statement of Python here. Let's say y is equal to x. Well, that will say, okay, y, you point to the same memory where you'll find the value of 3. But now let's reassign x to a new value, this integer 9. Okay, so x now points to 9, y still points to the 3 that it pointed to before. Now in Python, I can assign x a float value of 9.0, and now it points to that float value 9.0. That 9 may still exist in memory, that integer 9. Don't worry about that. That's Python's job to worry about that. And then how about if we say x is equal to the string 9? Well, now in memory, these characters n, I, and e will be stored somewhere, and the namespace will give the mapping from x to this string of characters. Now in some other computer languages, things do not behave this way. A particular identifier or name is always associated with a certain location in memory. In Python, it's not that way. It's the namespace's job to keep the mapping of names to objects straight.
Very good video. Yeah, I think that's about it for this video. So let me see the other one. No, this self is gonna be very hard to explain as well. I'm gonna have to probably link the two videos, so use the same resources, because in order to explain this self, that's the reason why I put scope first, because it's easier to explain this and self after explaining scope, because it's relative to. So I'm probably gonna use the same resources for both videos, and then the only thing that is gonna change is with the code that I'm gonna use for the this and self. Yeah, for this, I think I'm gonna, this and self, I'm gonna put the code side by side in the same way that I did for the methods videos. So I'm gonna get some code that uses the this keyword in JavaScript, and then some code that uses the self keyword in Python. Or I'm gonna think about the examples, and then I code the examples, and I put them side by side to explain the concept. Yeah, but I think I'm gonna stop here because I wanna do the video. Otherwise, if I structure another video, then I think I'm gonna have too much stuff in my mind. It's better to do one and then to structure one and then do the video so I can get all this stuff out of my mind and then go to the next one. Then to structure a bunch at the same time. So I think I'm not gonna stream today anymore. I'm probably gonna watch I'm gonna do this video right after I finish here, this stream. I'm gonna film this video and then I'm gonna watch these other videos here. I'm gonna have to watch these videos to do my video. All these videos about storage and all this stuff. And I'm also, I think I want to watch as many of these videos as possible. Probably, I don't think, maybe I'm not going to be able to finish today, but probably try to finish by tomorrow, all these videos here. And yeah, and so probably, and I might work on the this and south video off stream because they are very similar in the resources. It's just the code part that is different. So if I'm able to do, and also I have to finish put the 5 icons on the landing page and then post the video on the landing page. So hopefully by tomorrow I can continue from the classes point if I'm able to finish all this stuff today.